Hi everyone, my name is Valeria and I'm here to talk about my project regarding document validation for a company called Fido. And before we start, I want to mention that I am here representing a group of 3 students, which included also Yuval Fisher and Avital Lampert. Our mentor was amazing Dina Bavli, and on the Fido side, we were honored to work with Noah Lubin and Benjamin Gutelman. But before we start talking about models and metrics and everything, I want you to meet Maria. So that's her. Maria lives in a village and she grows watermelons in her garden, and she wants to sell these watermelons in the local market. So she starts planning, and turns out that she needs to hire a truck to transfer them to the market, and rent a stall in the market, and buy the gas for the truck. So expenses, and if she lived, let's say, in Israel, she could go to the bank and ask for a loan and maybe open her small business with this loan. But Maria lives in Ghana, and in Ghana, only 33% of adults still do not have a bank account. So their access to credit tools is extremely limited. And this is where even more, okay. I hope everyone hears now. Yeah, so she lives in Ghana, and in Ghana, access to credit tools is extremely limited. So this is where the company Fido comes in. Fido is a company that provides small microloans through mobile app to customers who do not have bank accounts. So these loans start with 200 Ghanaian cedis, which is roughly around 15 American dollars. But in order to increase the credit limit, the customer can upload some supporting documents. These documents could be, for example, the documents that prove their address. It can be a rental contract, it can be a water bill, it can be other utility bills, or it can be a document that proves the employment of the customer, namely a work contract or a payslip. And right now, these documents are labeled manually by employees of Fido. So this is an obvious bottleneck, and the company wants to automate it. But before talking about automation, let's take a look at the data that we have. We have the documents, but these are not really the documents. These are scans of the documents, or even more often, these are just smartphone pictures of these documents. And that's what we need to work with. So the rough flow of the data is 17,000 documents per month. And right now, their approval time ranges from 1 hour to 8 days. So you can see there is a lot of room for improvement here. Now, when we talk about automation, how do we do that? So there are 4 very small and clear steps. First of all, we have the document as a picture, but we don't want the picture, we want the text of the document, right? So we want to extract the text from the document and use it. Then we need to figure out which document we're actually working with, if it's a rental contract, or if it's a water bill, or if it's a bank slip. So professionally speaking, we need to perform a multi-label classification. And luckily for us, Fido doesn't accept all the documents in the world. They accept only a closed list of 13 documents, 13 types of documents. So we know what to look for. Then we need to verify the category of the document. Namely, we need to figure out if the document serves its purpose. If they uploaded it as a proof of employment, then we need to make sure that it's either a bank statement or a work contract. And finally, we need to search for customer name in this document and to make sure that it appears in the document. So 4 very simple steps, right? And this big and scary schema is basically the same 4 steps, just when we add a little more detail, a little more explanation to every step. So I think I'm gonna skip this slide. Just trust me that these are the same 4 steps. With more details. And while we were implementing these 4 steps, we faced several challenges. And first challenge was with the text extraction. So there are a lot of great tools that cost money and do their job brilliantly, but we started with the free open source tool, and I tried several different open source tools, checked their quality. So the best quality was by Tesseract. Tesseract is an open source tool that was developed by HP. And not only they have quite a good quality, but also they have a cool feature. They predict the angle of the text, because not all of our documents are actually located correctly. Some of the documents need to be rotated in order to read the text. So this tool has a feature of the text angle prediction, and after that you can write a script and turn the document however you need. The downside is that Tesseract is rather slow. It takes about 6 seconds to go through a document, and if we have thousands of documents, it honestly makes a lot of difference. So the second challenge that we faced was the imbalanced data set. And remember I told you that we have around 17,000 documents each month. So only 5% of them actually get approved. All the other can be either spam, which means it's a document which had no text at all, so it's completely not relevant, or it can be a document that is maybe relevant, but it was rejected for some reason. Why it was rejected? There are different reasons for that. It could be the document just is too old, or the quality is not very good, so it's not readable. Or, for example, the customer name does not appear in the document, or simply it's not the type of the document that Fido actually works with. So anyway, only 5% of the documents were approved, and on top of that, we had some minority categories which had very few samples in them. And I can, generally when we train the model, we want to train it on the train set, do the validation on the validation set, do some twig in the hyperparameters, and after it's all done, we want to test it on the test set. So in my case, we had some classes which contained only 2 samples, so we couldn't even distribute them evenly between train, validation, and test set. And the other challenge that we faced, and it was, I think, the biggest challenge in this project, was that the documents, the rejected documents, were not labeled as I would want them to be labeled. Namely, they did not have the clear rejection reason. And I can explain to you why it's not very good for the model. Imagine you have 2 bank statements. One is a perfectly legit bank statement and it's good, and the second one is also a legit bank statement, but it's just 3 years old. So when the manual labeler takes this document, they reject it, and it makes perfect sense, it should be rejected. But from the point of view of the model gets 2 documents, they are the same documents, but one is a bank statement and the other one is rejected. So of course it obviously harmed the accuracy of the model, and how we dealt with it, actually there was no good solution for that. So we started by building the model, training the model only on the small subset of approved documents, and later after that we added more, we introduced the rejected category, but after we introduced the rejected documents, the accuracy slightly dropped. And now about the model. So I'm saying model, but actually what I used was the ensemble of 2 models, computer vision, the one that classifies documents based on how they look, and NLP model, the one that encodes text into a vector and classifies documents based on this vector. For those who did not study data science for the last year, I'll tell that usually you don't build these models from scratch. You don't need to invent a bicycle. You can just download the existing architecture and pre-trained model from some hub, like from PyTorch or from Hugging Face, and then you can just fine-tune it on your own data, on your own task. So that's exactly what I did. I chose the MobileNet model for the computer vision, and this actually funny story, I chose it because, as you can guess from the name, it's really light and it can run on a mobile phone. So I trained it on some data, I presented the results to the company, and then turned out that they already used the same architecture for other tasks. So it was a great fit. So MobileNet for computer vision part and BERT for the NLP part. And I trained them and I got pretty good accuracy. It was 80% accuracy on computer vision model and 90% on BERT. Of course, when I introduced rejections, the accuracy slightly dropped. Now, you're looking at this and you're probably thinking, why would we use the model ensemble when we can just take BERT? Because BERT performs much nicer than computer vision, so why do we even need computer vision? And that's a very good point. We maybe don't need it, but the structure of our data is such that our documents contain not only text, but they also contain some visual, they have the visual structure that is very recognizable. So I decided that if we are using the computer vision model, we are augmenting our result and enhancing it. So I kept it, and then the next question is, if we have two models, how we make an ensemble out of them, how we combine their predictions. So I combined their predictions based on the error analysis. I took a small test set, and I ran both models on it. And then I compared the errors. So there were cases when both models gave the same answer, which is perfect. And then there were cases when both models made a mistake, which also happens. But then there were also cases when one model gave a correct answer and the other model made a mistake. So I analyzed these cases and I looked at the distribution of the softmax scores in these cases. And again, for people who are far from data science, softmax score is the score that you, like when you are training a classifier model, you do not receive, you feed it a document, you do not receive an answer, that's a bank statement, or I don't know, that's a water bill. You have 13 categories of the document and you receive 13 scores. And each score looks, it's an output of softmax function, and it looks pretty much like a probability. It's not a probability, but it looks very much like it. It's a number from 0 to 1, and it shows basically how confident the model is that the document belongs to this category. So I checked the distribution of softmax score, and first of all, what I saw is that the softmax scores for computer vision model were in general, on average, lower than for the BERT model. It means that even when computer vision model gave the correct predictions, it was kind of not so sure about them. So this distribution helped me figure out which thresholds to take, and after that I created the following logic. So if models agree, it's amazing, we don't need to choose. If models disagree and the BERT model gives the prediction slightly above average, but computer vision model gives the prediction, sorry, if BERT predicts something with a confidence below average, and computer vision with the confidence above average, then we use computer vision prediction. Or if the predicted category by computer vision is either water bill or electricity bill, the categories which have very strong visuals, then we're taking the computer vision predictions. Else, we're using BERT predictions, and I know it's a little too much to imagine, so let's look at the example. For example, this I took the test set and I took all the water bills from this test set. And I took the cases when computer vision model was predicting the correct answer. Here, this is the left box plot. And we see that it was predicting water bill very, very confidently, because average score is 63%, but it was predicting with a score between 80% and 100. And for the same documents, the BERT model was predicting something else. It was saying Maybe it's an appointment letter, or maybe it's a payslip, or maybe it's a rejected document. But the score was above average, because average score for NLP model was 83%, and all these predictions are all these softmax scores are much lower than 83%. So in cases like this, we would be using the computer vision score. Now, I use this ensemble to evaluate our test set and calculate the main metrics, like top 1 accuracy and precision and recall. And all of them are roughly 80.7%. And here on the left side, you can see the confusion matrix, which shows us the results by category. So in this matrix, each row is a true label, and each column is our prediction. So what do we want? We want our prediction to match the true label. So basically, we want very good, very high scores on the diagonal. And for most categories, that's what we get. Exceptions, hiccups like this, they are actually the results of these minority classes that I mentioned, the classes which I didn't even manage to split to train and test set. So overall, this is the result. We have the model, we have the prediction, and we forgot about name matching. Name matching was the final challenge that was also pretty complicated. So you would think that when you have a name and when you have a text, you can just search for the name in the text and find it. And then turns out that it doesn't work like this, especially in Ghana. They have a lot of middle names, they have a lot of different spellings, they can spell something with a hyphen, without a hyphen. So I had to use the technique called the fuzzy matching. Fuzzy matching basically means that you take the string and you search for variations of this string. You use something called the Levenshtein distance. It's the distance between, it's basically how many changes you need to make in one string in order to get to another string. So the to-go library for it is Fuzzy Wuzzy, which works great, but it's really very, very slow. So I started looking for maybe some ways to make it faster, and turned out that someone already did it and just created another library called RapidFuzz, which is written not in Python but in C++. So it does all the same job but 6 times faster. So I used it, and now finally we can say confidently that we've managed to achieve the goals of our project, to train the multi-label classifier with the top 1 accuracy of 80.7%, and build a functional end-to-end pipeline for for text extraction and document evaluation. There are, of course, several things that could be improved, and I'll talk about one of them. That's like an extra result of my project. So if you remember, I had a lot of issues with how the documents were labeled, especially how the rejected documents were labeled. After we did the analysis of it and shared it with the company agreed that they could have been labeled better. And as far as I know, they are looking into reviewing some of the previously labeled documents. So they asked if I have any suggestion how to label them, and I created the algorithm for tagging them. So the algorithm is really simple, and it can be implemented in, for example, Google Forms, but I wanted to show off. So I actually created a design prototype of it, and I hope that this will open now. Yeah, it does. Okay, so this is the design of the tagging tool, and this is what the labeler will see. So they will see the document, and they will see which category the document belongs to, and they will see what's the name of the customer, and then they have to answer several closed questions from the list of closed answers, like if you can open the file, if the quality is good enough to read it, which category it is, and again it's a closed list, so you cannot choose something that is not here, if customer name matches, if the document is expired or not, and so on, and then they just submit it, and basically they don't have to make a decision, because they just describe what they see, and whether the document is accepted or the document is rejected, we still see all the information on this document. So that was my tagging tool, and I think that's the end of my presentation. Thank you all for listening.
How have you dealt with the fake documents?
That's a great question. So honestly, I did not have a lot of them, mostly because these are. I can describe which fake documents we got. So we got a document which is a scan of, let's say, an appointment letter, and then someone just takes a pen and instead of one name in the document writes their own name. So it's a very amateur level. For now, we did not really deal with them because we had only around 100 documents like that among 170,000 documents that we reviewed. And that's still an open question, how to deal with them. In fact, if you see, so here the possible improvements include some binary classifiers. So basically we can try to add another model which will distinguish these obviously altered documents, obviously fake, from real ones, and then kind of fish them out of the data set before we do the main classification. And that's probably the only method. Please?
When you built an ensemble, you wrote hard-coded logic with 60% and 80% of several classes in order to decide when to take which option.
For now, yes, but I added them as global constants,
Yeah,
so they can be...
Generally, did you consider using an ML model for that gets the output of the two models and combines it? Just a regular logistic regression would have probably done the trick better than a hard-coded logic.
That's a very good suggestion, and if I wasn't running out of time when I was finishing the project, I would have probably tried to automate it somehow, because in my case I was just trying to wrap it up already. Thank you.